Hello and welcome to Console Cowboys. So now that we know how signing works and we know how transactions work and cryptography on the blockchain, let's continue on where we left off with our programming and grab the actual transaction info from the blocks. So if you remember correct, we use this get block method within our code, and we did that via grabbing the block number, taking that block number, putting it into a get block function, and pulling back our block info to print that out. And that gave us all the information on the block. We could take a look at that really quick. So we have all the information on the block, but then all we had was transaction hashes. We can look up those hashes on Etherscan, but what if we actually want to print them out programmatically so we can filter things out or do some kind of business logic with it? So to continue on with that, if we look down within these block methods, right here within the documentation, there's a get block with transactions, and it says, get the block from the network where the result.transactions is an array of transaction response objects. So that has all of this information in here, which is the information within the actual transaction that we saw on Etherscan when we took a look. So let's add that right into our code. So we knew that pretty easily. We could add it to here. All we need to do is grab the block number and send that in just like we did with get block, but we're going to do get block transactions this time. But this time, let's create another function that handles transactions so we don't muddle all of our code within something called inspect block. Let's do inspect transactions instead. Since this actual functionality we're building is not going to inspect the block, it's going to inspect the transactions within the block. Just makes logical sense. So we can say const inspect transaction, and we'll make that an async function again so that we can wait for the results. And within here, what we want to do is we want to grab the transactions with get block with a transaction. So we could say create a variable, and we'll call this transactions. We'll grab the object into here. And then we'll say we want to wait for that, so await. And we'll use our provider. If you remember what the provider was, it was our connection to the blockchain using Infura. So we got provider, got get block with transactions, and all we have to do is pass in a block number. So block number. Now, how do we get that block number? We get it from our previous function, which already has it, right? So we have our block number right there coming back in a variable. So from here, why don't we just call our new function, right? So we say inspect transaction, and we'll place the block number in there. So now we're going to send our block number that we already have from this function, and that's getting called right from the beginning of the actual program, and it will send that over to our inspect transaction. So we're going to need to add that as an argument coming in, and then pass that right into our get block with transactions. So now what we have is we should have a block with an array of transactions. And we can log those out, same way as we did above with console.log. And we'll say transaction. And all we're going to do is put in, say, the first transaction should be 0. Based on how numbers work in programming, 0, 1, 2, 3, 4, 5. Technically, it should be 0. We'll find out in a second. So this code looks pretty good. Let's actually run this now. So we should see first, we saw the stuff from before print out. So here's our previous block because we didn't get rid of that log statement. Once that was done, it grabbed number 0 here and it passed that down into here. So here's our hash, and here's all of our information for what's actually in the transaction, right? So let's see what we got here. So within here, we have our transaction hash. We have our block hash. We have where the value or whatever this transaction is doing is coming from. We have where it's going to somewhere in here. There we go. And we have some data being sent across here. So if you go on to Etherscan, you can see these data fields. Actually, you have to hit a drop down to see them. And sometimes it's like the function that's being used, or other times it's other data that can be decoded. So if we took a look at, say, this transaction hash, and we popped that into Etherscan here, we pull that up and scroll down, you'll see this click to see more. And here is the input data, and you can usually change like the encoding and representation of it with this view input as. This is the default view where it usually decodes it for you automatically. There's also an original view. It's not going to change it here because just based on how the representation is here. But if we look at other transactions going on right now on the blockchain, we can take a look at the different types of input data just really quick so you get an idea what I'm talking about. So if we click one of these guys, there's 293 transactions, and we scroll down, you'll see like a transfer. Now transfer probably has 0x within that because that's just the way the transfers are. That's what the data is. Oh, this is actually a transfer function, so that's actually interesting. So here's the representation of that transfer function. You have your address to and your uint, and then down here, if you figured out what the offsets are and such, you'd see the values that were sent into this actual function as the data. And then if we actually click something that's just a transfer that's not a transfer function, see if we get one here. It should just have 0x in there. So we pull that down there, it's just 0x, and this is just a regular transfer. The other one was actually using a transfer function within a contract is what my guess is. And you'll see that this is transferring a value of 300 or 0.27 Ethereum as of today. So back in the actual transaction, you can see the same things, right? We have the gas price, we have the gas limit, we have the value, but that's actually in a big number within underscore hex. So we could parse that out directly if we want. This would be the value. So let me grab that here. We could say transactions.value underscore hex. So now if we run that, it should parse only that value out instead of the whole transaction. All right, so it did that. So that's what that value is within that value underscore hex parameter. And we could use like big number functions within the Ethers.js to convert that to something meaningful to us if we want. But what we're gonna do now is run a loop through all the transactions, which would be useful if maybe we were looking for, all transactions above this, value, or everything with, this high of gas fees, etc., to kind of get an idea of what's going on within that block. And we can easily do that, just like in Python where you have like that for value in values type of loop. There's like a for each loop in JavaScript that we can use. Format's not as intuitive. You're kind of like passing a function into a function type of setup, but it's not too bad. So we'll say transactions.for each. So we're saying for each transaction, we'll say function transaction. And that's similar to Python where you're just saying like for transaction in transactions, right? So this transaction value right here, we can use this within the brackets here and we can do whatever we want with it. So we say console.log transaction. And that's, the same thing really as what we just did where we said transactions bracket 0, except we're saying transaction bracket 0, 1, 2, 3, 4, 5, and then we can parse data out from that. So if we did that now, just as a proof of concept to make sure that it's actually working, we'll go back here and it will grab that block for us, and then it'll parse out all these transaction hashes. It'll just parse out like the whole transaction instead of just the hashes now, because it'll use that loop to pull them down. So we'll see there's all the transactions that went through. If we scroll up, we're going to just see one after another after another. So then we could just start parsing out for things and using if statements to check various values if we wanted, or we can just print out certain data, kind of like we just did the value big number. So we could say maybe we're going to parse out everything in the to field because maybe we're looking up everything going to a certain address and setting up some events on that. So let's see, we'll go transaction.to, and that'll pull back the 2, and maybe we want the hashes with it as well. So console.log transaction.hash, and that'll pull back all the hashes and all the 2s, but not the whole actual full transaction like we just did. So let's give that a try. And I'm just showing you guys a bunch of stuff so that when you're working on your own project or trying to play around, that you have some more options to work with. So we're just playing with some different ways to do things. All right, we have an error here, so let's see what that is. Unhandled promise rejection, transaction not defined. Array for each. So let's see what we got here. Oh, I spelled that wrong, so that would be what is wrong there. So let's hop back in. So now we're seeing values scroll down the screen, and this would be the transaction hash, the 2, the transaction hash, the 2. So now if we wanted to say, look for a specific 2, we could probably just parse that out with a regular if statement or something of that nature, and then we'll get all the transaction hashes associated with all those 2s, and then we can look into those further by writing more scripts that analyze data. I could just do that right now, but it'd probably be pointless because one of these 2 values probably won't be in the next block by the time we code it, but you kind of get the point. This is how to work with this transaction data. So hopefully all of this was useful. In the next one, we're probably going to look at pending transactions, but we'll probably first look at like attacks associated with pending transactions and where those pending transactions lie, because they don't lie within the blocks where we're looking at them now. It's actually before they're put into blocks, and there's various attacks within DeFi associated with those. But hopefully this coding kind of gave you some ideas on how to work with transactions, how to parse some data, how that data is situated within the blocks, and you got some previous information on the signing and the cryptography associated with it. So kind of like bringing this all together as far as how these network transactions and blocks function within the blockchain, and actually being able to do something real with them with code, not just talk about them theoretically. So as usual, hopefully you learned something. If you did, like, subscribe, share it with all your friends, and I'll see you in the next one.